This is for class 12, that is inductance. Inductance. Here comes the word flux linkage. Flux linkage. This is proportional to the current flowing through the coil. Flux means current flowing in this coil, and the flux linkage in this current is flowing in this coil and the flux linkage in this coil. So here phi is proportional to I. If there are n number of turns, then your n phi is proportional to I. So when the proportional sign is removed, a constant is given, and this proportionality constant is called inductance. This proportionality constant is called inductance. Now there are two cases. One is the mutual inductance, and other is the self inductance. Self inductance. Other is the self inductance. Now I will be discussing about the mutual inductance. Here you see mutual inductance, that is we are considering two coils, one smaller coil and another a bigger coil, which is the smaller coil is inside the bigger coil, and we consider the length of the coil, means it is after a solenoid L. This is S2 coil and the smaller one is S1 coil. The radius of this S2 coil is R2 and the current flowing through is I2, and here radius is R1 and the current flowing through here is I1. Now the first case is that I2 current, we are taking the bigger coil, and here I2 current is flowing through the bigger coil of radius R. So your flux linkage will be in the smaller coil. Flux linkage in the smaller coil. Bigger coil, it has N2 number of turns, and smaller coil, it has N1 number of turns. Here we this is N2 number of turns per unit length, and here N1 number of turns per unit length. This is N2 number of turns per unit length, and this is N1 number of turns per unit length. So here for the current is flowing in the bigger coil and flux linkage in the smaller coil. So N1 phi 1, that is will be equal to M12 mutual inductance of 1 with respect to 2, and then the current flowing, that is I2. We know that the magnetic field inside a solenoid is constant. N is the number of turns and I is the current flowing through it. And also we know that phi is equal to BA, magnetic field into area. We know this. So your phi 1, this will be equal to B into A. B is this constant, and because of this bigger coil, it is because of the bigger coil, current flowing in the bigger coil, and for the bigger coil, the flux in the smaller coil. So bigger coil, so this is N2 and the I2, because we are considering the current flowing in the bigger coil and the flux linkage in the secondary, in the smaller coil. Remember that we are considering the current flowing in the bigger coil, but the flux linkage with the smaller coil. And this is phi into area pi R1 square, because we are considering the smaller coil. And next, your N1 phi 1, your N1, this is N1 is the number of turns per unit length. So total N1 will be equal to N1L constant N2 I2 pi R1 square. So this becomes N1, let me write the constant first, N1 N2 L pi R1 square I2. Now If you compare these two equation, if you compare these two equation, your M12 will be constant, and 1 and 2 L pi R1 square. Now we are considering the second case. In the second case, your current is flowing in the second case, the current is flowing in your primary coil, primary say, in the smaller coil. Your current is flowing in the current is flowing in your smaller coil. So the we are considering calculating flux linkage of the bigger coil. So N2 phi 2. So this will be N2 phi 2 will be M 21 I M21 current flowing because of the we are considering here. Remember that we are considering here the current flowing in the smaller coil and flux linkage of the bigger coil. Remember here we are considering the current flowing in the smaller coil and the flux linkage of the bigger coil. But here there is an interesting fact, that is the since the current flowing in the smaller coil, your flux will be confined. Your flux will be confined inside the smaller coil. Your flux will be confined inside the smaller coil. So your phi 2 will be constant N1 uh, N1 for the smaller coil N1 I1, because here it has been considered that the flux linkage will be confined in the smaller coil. So we have to take the case of the smaller coil, and then this is the flux B into A, area will be pi R1 square, because the flux is confined, in the smaller coil. It has been considered, no doubt the current is flowing in the smaller coil, and we are considering the flux linkage of the bigger coil, yet it has been considered, yet it has been considered that the yet it has been considered that the Yet it has been considered that the flux is confined inside the smaller coil. So we are taking flux, that is magnetic field of the smaller coil and area of the smaller coil. So here again you see N2 for this N2 phi 2, N2 phi 2. This will be N2, that is N2L constant, N1 I1 pi R1 square. So this will be equal to N1 N2 N1 into pi R1 square L I1 I1. So if you compare these two, you find that your M21 is also constant N1 N2 pi R1 square and L. So here you see that this both, that means M12 is equal to M21. M12 is equal to M21. Here the important point here is that no doubt the current is flowing in the smaller coil. No doubt the current is flowing in the smaller coil, but and we are considering the flux of the bigger coil. But it has been considered that it has been considered that the flux is confined in the smaller coil, and here we come to the conclusion that mutual inductance due to of 1 with respect to 2 and mutual inductance of 2 with respect to 1, both are the same. So this is about mutual inductance. And another important point about self-inductance, it takes place in the same coil. And for self-inductance, the most important point here is that the self inductance, it acts as a back EMF. It acts as a back EMF. It acts as a back EMF. So in self inductance, it acts as a back EMF. So it acts as an this it acts as a mass, as in mechanics. It acts as a mass, that is mechanics, and we have to do work. We have to do work against this back EMF, and we have to do work against this back EMF, and your work done here is equal to half self inductance I square, the current flowing through the coil. Here the most important thing here is that in self inductance, your this in self inductance, it act as a this back EMF. It act as a back EMF, and that means it is analog to mass in mechanics, and so we have to do work against this back EMF, and this work done is equal to half. This is self inductance into I square, the current flowing through the conductor. So this is all about today.